Okay, go to the next slide.
You got it.
All right, great, thank you. Okay, so good afternoon, everyone. Thanks again for joining us. My name is Sarah Husky with 3C Ren, and I have started recording this course, which will be posted on our on-demand page. We have today Nick Brown with us to walk us through his all-electric accessory dwelling unit, also known as an ADU. But before we get going, I have just a few slides. Just a reminder to make sure that you're on mute throughout the course. And if you'd like to ask any questions, please raise your hand and we'll ask you to unmute yourself. I'll also be looking at the chat, so you can ask questions that way as well. And next slide. So just really briefly, a few words about who we are. We are the Tri-County Regional Energy Network, also known as 3C Ren. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services. 3C Ren is funded by ratepayer dollars, which are collected through the public goods charge. And the benefit of being ratepayer funded is that there's no cost to those we serve, and we're able to return these dollars back to our local economy, which has historically missed out on some of these funds. And we have 3 programs, the first of which is our Energy Code Connect program. And this program serves building professionals by offering Title 24, Part 6, and Part 11 support. We have our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for residential and non-residential projects. And we also have our trainings, which this training today is brought to you from. And then our next program is our Building Performance Training, which serves buildings by offering technical and soft skill trainings related to building science principles, high performance buildings, and communication techniques. And then our third program is our home energy savings, which incentivizes contractors and helps residents save money to make their homes healthier with energy efficient upgrades through incentives and rebates. And I'll just note that this year our program reserved their funding for the year. So we encourage anyone to submit interest forms, but we won't be doing any new projects until 2025. So with that, I'll pass things back over to Nick.
Thanks so much, Sarah. As always, you've got a good group here, good sized group, and we really welcome participation. Verbal participation preferred for me personally. So if you do want to unmute yourself and ask a question, I encourage you to do it at any time, or put it in the chat if you're more comfortable. I'm coming to you from Long Beach, just a little south of 3C Ren territory. And I was just up there yesterday in Ventura teaching plumbers how to install heat pump water heaters right as part of the building performance program with 3C Ren. So I love working with them. They've really separated themselves as excellent in terms of getting these resources and programs out in their community. So you all should feel lucky to live where they are. We're going to cover accessory dwelling units and make a strong case for building them all electric today. This is my ADU. As you can see, it was built above an existing garage. About the tenants have been in there 2 years and 3 months now. Working really well, and we're going to use it as a case study throughout today, but you'll come away with an understanding of how to do this for yourself. Now, a little about me. We remodeled the main house. You can see the garage there without the ADU on top in 2015, and we made it net zero energy. I was an energy consultant already by then, and everything was ZNE, net zero energy. Build an efficient building with some electricity, some gas, put enough solar on the roof to fully offset it over the course of the year, and Bob's your uncle, you've done all you can. But what I didn't know then was the key differences between all electric and mixed fuel ZNE. And it's just the perfect exemplification of my own learning process that I chose to build the main house, or rebuild the main house, with a gas furnace, with a gas tankless water heater. I got the induction cooking part right, but I had a gas dryer. And when it came time just, 7 years later, to build the ADU above the garage, and let me hit click and you'll see it change to with the ADU, I built it all electric. And it was easier than it would have been to build it mixed fuel. I think I've got another picture here to bring in. Here you can see the living area, the main great room of the ADU. So these buildings, although energy efficient and built to the progressive standards of the time, they're very livable too. They don't have to feel experimental. They don't take user intervention, or you don't have to live in them differently. And that was important to me. I teach a bunch of classes besides energy consulting, a lot of them on all electric for Southern California Edison and PG&E, as well as 3C REN. Also teach on the statewide Energy Code ACE team, the classes for single family architects, the solar and battery classes in particular. So there you go. Now, let me ask you to put in chat what you first think of regarding accessory dwelling units. And I put on the screen a word map from a prior iteration, prior delivery of this class. But what do you guys think about? Are you seeing a lot of ADUs built in your community? Yeah, Jason
Absolutely.
agrees with the income. Sorry, go ahead.
Sorry, I said absolutely. I'm in Santa Barbara.
Okay, seeing a lot.
Yeah.
And Santa Barbara has been traditionally slow growth, haven't they? But they've embraced ADUs.
Yeah, we're having a lot of people doing homestays and ADUs. Would say like maybe 1 in 5 people come in
Okay,
wanting an ADU.
yeah. I like Jason's comment too on in-laws. ADU is really well suited to multi-gen housing. You can live with the in-laws or the kids in the backyard, and they don't have to pitch a tent. Okay, Danica. All right, but I think one of the other things that has come up in discussions with about ADUs, expensive, difficult to build, sometimes hurdles with the regulators. We hear that too. This is from Casita Coalition. We're up to now 20% of California's creation of housing units is ADUs. Isn't that a shocking statistic? Where would we be if we were only relying on home builders to build new housing, if we hadn't unlocked the ability of families all over the state to add an ADU to their lot? An extra 20% is a huge deal, and yet still rents are rising and housing affordability is a real crisis, right? But I wanted to share these statistics with you. It's also interesting to me to see Los Angeles with a leader. Los Angeles's politics, aren't typically as progressive as many communities in Northern California, but I think it goes to show that it's that income potential, it's that build an ADU as a profitable investment that may be driving it as much as you know, the desire to do something good about the housing crisis. And some of the advantages of ADUs: it can work in small spaces quickly, relatively. It can help families take care of loved ones, have your kids be able to afford a place to live starting out, and boost equity. This concept that many families have, you know, they've accumulated some savings in accounts. They don't generally have a way to put $200,000, $300,000 to work in real estate. Nothing's for sale at that level. Well, ADUs enable them to do just that. And so the loosening of ADU laws around the state has unlocked this capital to build additional housing. So I joined Casita Coalition. Recommend check out their webpage and events, because they work to advocate for small housing all over the state. Do a nice job. And ADUs can serve many different purposes, whether it's a workspace, rental income, recovery space, adult children, studio space, if you're lucky enough, age in place retirement, right? Or like us, we rented to a young family. How about all electric now? There's been a lot of coverage of the state transitioning from gas homes to all electric homes. What do you think about that? Maybe some of you live in all electric homes already. Sounds expensive. Okay, Jason's already there. Yeah, and if it's up to your clients, it means you need to be the one educating them about the pros and cons and the differences, right? So you'll come away with some talking points from today. Yeah, hi, Sarah. Panel upgrades as a complication at times, yeah. Yeah, cost saving, only one utility. Especially when you're building a backyard ADU and there's not already gas back there, right? You need electricity, you don't necessarily need gas. And energy efficient. Great. Well, here's the piece I didn't understand when I remodeled my main house in 2015 and included gas systems. The greenhouse gas emissions of all electric homes are roughly half that of mixed fuel homes. And that's today. That's climate zone 3, San Francisco, climate zone 6, Long Beach, climate zone 10, Inland Empire, Southern California, 12, Sacramento, and all up through 3C REN territory. Notice that it's the orange slice that's the biggest cut. Water heating. Water heating is where you have the biggest opportunity typically in homes in California to cut your greenhouse gas emissions, but also heating and cooling, the blue bars. Yeah, so for a state that has aggressive climate goals that it's committed us to, all electric is the low-hanging fruit to decarbonize, to reduce greenhouse gas emissions in the economy. Together with electric vehicles, these are two of the easiest things that California can do. Hence the focus in the energy code, incentive programs, all throughout what you might be reading in your articles on all electric. So today we're going to talk about ADUs and all electric and why those why that's a good match. So this study from E3 back in 2019, it was a landmark study. It's getting a little old now, but still holds true that the capital cost, the first cost of building a new single family home in 4 major climate zones is less than building it mixed fuel. And part of that's Jason's comment in the chat from just now. If you don't have to run gas lines to the lots, I've heard 7,000 to 10,000, Jason, 15,000 maybe more accurate for an established neighborhood, I don't know. But that's a huge savings that you're gonna, even with small incremental increases in cost for those electric systems, perhaps, you're gonna come out well ahead. And that's why home builders like KB and Meritage, Beazer, I heard is all electric in California, have gone that way. Even multifamily buildings can be done the same way. And so I kick off today with the costs of my ADU, the gas system that I could have installed and the electric systems that I did install for comparison. I found that the heating and cooling system in a ductless mini split, it was about $10,000, and every contractor I asked said a gas furnace split system would have been about the same, and it would have had exposed ducts, or I would have had to add an attic. Okay, I see this hold true on my projects all around the state, that heat pumps are about the same cost as gas furnace these days installed. The heat pump water heater, these might be costing a little over $3,000 installed now. So it was a little bit more than a gas tankless would have been to install. But many of you may have found that to install a gas tankless where one doesn't already exist sometimes requires an increase in the diameter of the gas line. So boy, if you're facing that, the heat pump water heater is definitely going to be a lower cost option. Now, I did have to run a 240 volt circuit as part of the heat pump water heater install for the ADU, but I had an electrician here anyway, so I didn't treat that as an incremental cost. Cooking, the Frigidaire induction range with air fryer that we put in the ADU cost a little over $2,000, and the equivalent gas range just $100 less. Although, of course, you can find a cheaper gas range, but I tried to compare similar configurations. Clothes drying, definitely the heat pump dryer we chose from Miele was a little bit more than a gas dryer, but you add it all up and incremental cost of all electric systems is small. In our case, about $1,000. So I wanted to start off with costs because, well, I was an econ major and I have an MBA, and you can't just sweep the cost argument, the cost question under the rug. So that's why I thought I'd lead with it. And we'll talk more at the end about the economics of ADUs and what kind of return on the investment I think we're going to have. So in 2015, as I alluded to earlier, net zero energy was what progressive builders were talking about, and all solar was considered helpful to the grid. We treated gas and electric systems interchangeably, and our energy modeling software reflected that. Today, though, solar exported to the grid has less value than in 2015. And I would say solar that you can use directly in your house after it's produced has a much larger value than solar power exported to the grid. This is due to NEM 3 or net billing changes in the utility rate structures. They've recently reconfigured it. So you're not going to have the same payback on solar today that you would have in 2015 The rates have changed. We understand too, I showed you that stacked bar chart earlier, that all electric homes have a significant greenhouse gas advantage over mixed fuel. And our energy modeling software is caught up to all this. And now, when those of us who are energy consultants like Sarah, when we run our models, the software is giving us much more realistic feedback on the compliance score of our building, because it's taking into account the changed grid and all of the clean energy transition milestones that we've committed ourselves to, including by 2045, California aims to have an electricity system that's 100% emissions free. That was the SB 100 that committed us to that. So when it came time to design the ADU, really building it all electric was one of my main goals. I wanted to have a case study. I wanted to apply what I'd been learning in all the seminars I was going to. So we know that buildings account for 25%, by some estimates, 40% of California's emissions. So we can't address the challenge of extreme weather events without focusing on buildings. Vehicles, another focus area, of course. So to fight this, we need to, one, reduce building energy use through efficiency, and two, power it as much as possible with renewables. That concept of net zero energy that was in vogue in 2015 ignores the greenhouse gas emission differences between gas and electric and time of use differences. So this ADU, even without solar, by switching from gas systems to electric systems, the greenhouse gas emissions dropped 28%. And then we chose a reasonable size solar system, 12 PV panels, 4 kilowatts, to offset that. That put us right near zero net carbon. And I estimated by my spreadsheet back then, before NEM3, utility bills of about $142 a year. So everything supported this all electric zero net carbon design goal. See if you caught the subtle difference between zero net energy and zero net carbon. Oh, wait, I gave you the answer. Zero net carbon takes into account the carbon intensity of the grid on an hourly basis. So it gives you the incentive to design a building that uses energy at times when it's less carbon intensive. And you offset that fully with the production of a renewable energy system. Any questions on that? We good so far? Oh, Jason, thanks for backing me up on the gas line connections. Now, the energy code is one of the ways California can enact its climate goals. And it's very ADU friendly. I've noticed over the past few code cycles, quite a few pieces of the code that are clearly put in there to encourage ADU building and not discourage it through the energy code. So there are exceptions. There's no solar required in a new ADU if the solar size that would have been required is under 1.8 kilowatts. That's like 5 panels. Not cost effective to build a solar system that small, or certainly not as cost effective as larger systems. So they put that exception in. Note that that is triggered at different square footages in different climate zones. So work with your energy consultant to find out where that threshold is for you. I just answered a question for an architect earlier this morning, by the way. The threshold in climate zone 6 was 959 square feet, I think, under which you didn't have to do solar. In climate zone 8, just across the 405 freeway, it was 700 and something square feet. Anyway, Now, it's sometimes hard to find room for a heat pump water heater, 3-foot by 3-foot square footprint in an ADU. So there's an electric tankless allowable option if that home is under 500 square feet. Electric tankless aren't as efficient. They take a ton of power in the panel. I don't recommend them, but there is this exception in the code if you just can't find a place for the tank water heater. No whole house fan required if your home's small also. Other changes in the 2022 Energy Code, they made heat pump water heaters prescriptive standard in all climate zones. Not that you can't work around a prescriptive standard, but it certainly makes compliance easier with them than without them by a long shot, with the exception of 3, 4, 13, and 14. So that includes Paso Robles, Visalia, Central Valley, Bakersfield. A gas tankless is okay in there if paired with a heat pump for HVAC. If you do use gas systems, whether for a furnace, cooking, clothes drying, or water heating, you need to make it electric ready, which drives up the cost of the gas system relative to the electric system and gives you a little extra nudge to the electric option. All new homes also required to be battery ready because the Energy Commission anticipates that home batteries are going to be an important part of the solution. Also, a nice solid compliance credit and incentive to use a ductless mini split or some ducted mini splits for heating and cooling. And here's a little chart showing where the heat pump water heater is prescriptive standard and where you can get away with the gas tankless and the HVAC heat pump. Another important part of the code that makes ADUs just a little bit easier to build, well, a conversion of an existing unconditioned space to an ADU, you don't have to treat it like a brand new house. You can treat it as an addition. Perfect example of this is a garage conversion, right? But this could also be a storage shed or something else. Also, if you have an existing wall becoming part of the ADU, even though continuous insulation has been our prescriptive standard for several code cycles now, it's not required if you're just building an ADU in an existing wall, existing space. All you have to do is fill that cavity with the insulation it'll fit. R15 of 2x4, R21 of 2x6. R22 roofs also allowed in alterations and additions under 700 square feet. That can generally be done in a 2x6 cavity. So the typical ADU designs that I see, and thanks to ADU Homes for these images, an 1,100 square foot ADU in climate zone 12 can comply with a ducted mini split heat pump, a heat pump water heater in the garage, electric appliances. The prescriptive required solar array is 2.2 kilowatts, so only like 5 panels, 6, and 2x6 R21 walls, 2x12 R38 cool roof, and typical windows. The smaller ADU in climate zone 3 probably takes a ductless mini split, takes the electric tankless exception, electric appliances, meets the requirements for no solar, same walls and roof, but no cool roof in San Francisco, and high gain windows. So, very reasonable packages, nothing exotic there. Now, high performance ADUs have the same ductless or ducted mini split, definitely need a heat pump water heater, induction range better than electric range, heat pump dryer better than electric dryer, high performance envelope with air sealing like you see here. This is a factory built ADU company that I advised a few years ago. Really impressive how they were building these beautiful ADUs in a factory setting with larger solar systems than the prescriptive requirement. heat recovery ventilators, EV chargers, and battery storage systems all built in. All right, we doing okay? Any questions? About to cover how we convert from our typical gas systems to all electric. I should have mentioned, we've reserved some time to wander around my house and look at the induction cooktop, the heat pump water heater, can even show you the heat pump dryer if you want. Because sometimes when these systems are new, they feel so exotic and strange, and sometimes just seeing them is helpful. So I'm going to do that with the time at the end. All right, well, this pie chart shows gas use in typical California homes. You can see almost half of it is water heating. Next biggest slice, space heating, and then cooking, clothes drying, and other come in, well behind those two biggies. And we have systems to go all electric on all of those items, even electric fireplaces. So let's talk about some of the ins and outs here. Starting with induction cooktops. They work as these famous chefs here are showing you. And I added Yan Can Cook because I grew up watching him on San Francisco news channels. He also loves induction. They work by heating up the cookware, not the air around the cookware. They use magnetism to excite the molecules in the ferrous pan. That heat gets transferred directly into your food. And estimates are that induction cooktops transfer 80+% of the electricity into your food, whereas gas cooktops are about 40% efficient. The rest of the heat in the gas you're burning is being lost in the space, right? And heating you up as a chef, right? Perhaps the biggest reason to electrify homes out of everything is no combustion byproducts. I never thought about it growing up, but you wouldn't roll a propane barbecue into your living room to cook a meal, would you? And yet we're not doing much different to that, cooking over a gas cooktop. And studies recently show, I think I've got a slide coming up on that, significant health benefits from removing gas combustion from our conditioned space. Safer for kids to touch. You can picture them leaning up over the stove. What you doing, Dad? And there's significant differences because you're not heating up the whole area. You're just heating up the local pot and its food. They turn off when you pick off the pan, boil water in half the time, as you'll see in a little bit. I'm going to make us some rice. They have digital controls, many of them, which I think many people really appreciate. So the biggest barriers, inertia. As this poll from Quebec, my fellow energy consultant, shows from just a few years ago, we asked, what do you think the obstacles are on your projects to all electric? And gas cooking came in well ahead of everything else. Here are some of those studies recently on the health impacts of gas cooking. I want to spend just this one slide on it. First, the AMA came out with a statement, gas appliances increase risk of childhood asthma. Couldn't be more clear than that. And we've got a lot of childhood asthma in California due to our outdoor air being challenging. Another study found 4 out of 9 natural gas cooktops exceed the NOx concentrations that are allowable for outside. Another study found 90% of homes exceed NOx limits after an hour of cooking. And gas clothes dryers also are burning gas in our conditioned spaces. When they're venting, they're pulling in 150 CFM of outdoor air that you need to condition. So every reason to electrify, especially those two end uses, cooking and clothes drying. This study by Lawrence Berkeley National Labs found that it compared gas cooking to induction, gas in black, induction in red. And you see the big NOx spike that happens with gas just isn't there for induction. It's nothing to do with cooking. It's everything to do with burning gas. Ultrafine particles, about half as much cooking with induction. And particulate matter, well, that's just a function of cooking. So pretty similar with the two. All this to say, you still need a vent hood over an electric or induction stove because you're producing ultrafine particles, you're producing moisture, don't get me wrong, but you're producing a lot of pollutants with gas that you don't produce cooking over induction. And in terms of the obstacle of inertia, this study by SMUD found it confirmed about 80% of people before trying induction cooking were negative about it. And once they tried it, 91% were positive. Really seems like more of a perception issue than anything. And manufacturers are starting to come out with a lot of great options. This picture on the left is from an ADU that I designed the energy systems for. It's a 120 volt induction cooktop. This was a small studio ADU. It's not going to boil water in half the time, but it's going to do a perfectly adequate job of cooking for this small unit. Channing Copper, shown on the right, is a really innovative company out of Berkeley. They've devised a way to have 120 volts power a full-size range by giving it an onboard battery. It stores power over the course of the day for that usually 30 to 40 minutes you use to cook dinner. And all it needs is the 120 volts and it augments with its battery storage. So great way to fit induction range, which normally is 240 volt, 40 amps, into an existing panel size. They're a startup, so you may not see their product available just yet. Sorry, I had the IKEA picture up there earlier, didn't I? A lot of induction products available at IKEA, and there's Channing Copper. I have a friend who I've been, I guess I've been his electrification doula, helping him electrify things one step at a time. And when he finally got his induction range, water boils kind of quickly. And he sent me this picture of his fried chicken, came out great. And this is typical from what I hear from people who try induction. How about you guys? What are your impressions of induction? I'll be honest, full disclosure, one of my wife's coworkers I talked to the other day, she hates her induction cooktop. It's this, I won't say the brand, but for some reason it came with induction elements under the surface that are too small. They don't match the pan size outlines above. And so she's had to return that. But besides her, I mean, she's the 1% that I've heard don't love induction. It's a lot like switching to an electric car. People just don't go back. You see, the easy to clean resonated with people last time we taught this. Okay, hotter than you expected. And that's just a 120 volt unit, nowhere near the power of a full-size one. Yeah, but I bet it wasn't hot around the pot. And I find it's also, I can rest my spatula on the edge of the pot because there's just much less heat around it, and the concentrated nature of the heat at the base of the pot really focuses it on the food. Yeah, the surface will be hot where the pot was after you cook, transferred from the vessel, right? Anyone else impressions on induction? Well, you can, if not, we can save them till I go over there and make some rice. Let's turn to the next, I would say, biggest impediment to electrifying in some people's minds, and that's water heating. Heat pump water heaters are an enabling technology of all electric because they're 3 times more efficient than other electric options and gas options. You see, electric tank water heaters, the old style, are like heating your water with a toaster element. You're putting electricity through that wire, and the resistance creates heat. Doesn't seem like a good way to heat a full tank of water, does it? Whereas heat pump water heaters, they take the heat out of the air around them. They're not creating every BTU of heat. They're just moving it into the tank using the compressor cycle. They're able to get over 300% efficient as a result. If we were trying to electrify homes with toaster style electric water heaters, we'd be looking at high utility costs, low efficiency. We still might be doing it if heat pump water heaters didn't exist, but these are really enabling cost-effective all electric. I'll show you the 240 volt heat pump water heater that I installed for the ADU. That worked so well, electrified the heat pump water heater for the main house using a 120 volt plug-in model. That's been working equally well. And I did that because my gas tankless had an outlet there. And so I was able to remove the gas tankless, put the new water heater in that same spot where all the plumbing already was, and plug it right into the wall. Whereas a 240 volt, I would have had to have hired an electrician for that job. They can also do load shifting. They can elevate the temperature set point when power is cheap and then coast through peak periods. So the utilities are very interested in that function. They dehumidify the surrounding space and cool it. As you'll see, the one for the ADU cools my workbench in my garage as an added bonus in summer. Of course, makes it a little cold in winter. So you do have to think about the fact that the heat pump's taking the ambient air around it and spitting out cold air when you place it. Also makes a little bit of noise like a dishwasher. So you've got to consider that. And it needs a lot of air. So you can't put this in a closed off environment like a closet unless it has a fully louvered door or big grills on the top and the bottom. There's several different solutions to that, which we talked about yesterday in Ventura with your plumbers. But I find my ADU, it's a 50-gallon, it's more than adequate, and it's using 20 to 35 kilowatt hours a month. I think the peak of winter, it's more like 45, but very efficient. I think you'll agree that's peanuts to pay for water heating. Probably about what you're paying for gas water heating too. So basements and garages are good spaces because they've got a lot of area to draw air from. Outdoor closets are good, but not this picture in the middle. This was a client of mine that put it in here and didn't give it enough airflow. That door should have been fully louvered, and they had all kinds of trouble with it until I helped them correct it. And now it's fine. Indoor closets work too. Again, fully louvered door. Or you can duct the inlet and the outlet to outside if you prefer. Now, heat pump water heaters are what I call energy sippers. And the first hour rating is a measure of how many gallons per hour a water heater can supply to the house. A heat pump water heater has lower first hour rating for the same size as a gas water heater. So let's take a look at the gas 50 gallon, for instance. 85 gallons per hour it can provide in the first hour if the tank's fully stocked. But a heat pump water heater of the same size is under 70. A 65 gallon heat pump water heater about 75. And the heat pump water heater that's 80 gallons can do about 88. So we say upsize the tank of a heat pump water heater compared to the size tank you would have used if gas, 1 or 2 notches. This is because the recovery rate of a heat pump water heater is down around 25 gallons per hour, whereas a gas burner is bigger. Okay, more like 37.5 is what we've got on this chart. But I'm here to tell you that just like we've oversized our HVAC heaters, our furnaces, we've oversized our gas water heaters too, in most cases. And the extreme case is a gas tankless water heater. That's going to a duck hunt with a machine gun. No family needs unlimited hot water. No family. And yet we've decided that's what every, lucky family should have. We've sort of got to put that paradigm on the scrap heap of history and realize, hey, a right-sized heat pump water heater is going to service us just fine. I run both mine in heat pump only mode, which is the most efficient mode, but they come with backup resistance elements. So if you are showering the soccer team at your house, well, that backup resistance element will kick in that one day of the year and help get you through that high use period that's unusual. If the whole family's there at Thanksgiving, right? But most of the time you're going to be able to get by just fine on that 350% efficient heat pump.
And Nick, there were a couple of comments in the chat, the first of which was from Tim.
Small diameter. Yeah, they're all about the same. I would say they're about 2 feet in diameter. You trying to fit it in a small space, Tim? Yeah, that's the drawback of heat pump water heaters. Now, there are some heat pump water heaters that are split systems. So instead of having the heat pump on top of the tank integrated into the tank, you have a tank that's connected by water lines to the outdoor unit. Sanco 2 is the most well-known brand. So that could enable you to have a tank of various sizes. The other advantage of a split system heat pump water heater is the noise is outside now. The air source is outside now, so you don't have to worry about if it's in a small closet, will it have enough of an air source, of a heat source? So that might be a solution to you. Yeah, Deborah in the similar situation. Yeah, that closet must be real small. If you can't fit a 2-foot diameter heat pump water heater in there. They're also taller than standard water heaters because the heat pump is the top 18 inches probably of height. So that's sometimes an issue. Note that you don't have to put it on a pedestal in a garage like you do a gas water heater. So if you're coming up against height restrictions, you can remove that platform. Well, you guys brought up some of the main questions. Got to find a suitable location for it. But the last two are not true. They aren't less efficient to operate. They're much more efficient, and they can't be installed just the same as we always have. And that's why we were teaching that class yesterday in Ventura. Just a few things you've got to change, not overly complicated, and you'll have good results. All right, let's move on to HVAC. Oh, okay, Deborah's got a real small closet. Yeah, one won't fit in there. I'm sorry to tell you. Yeah, I've seen multifamily buildings where they have an electric tank water heater, what they call shorties, in a cabinet. Well, there's no equivalent space, form factor for a heat pump water heater to drop right in there. So they end up, adding a cabinet onto the kitchen cabinets to house it with a louvered door, or they put it in the hallway of the multifamily building in a maintenance closet, and they service it from outside the unit. Sometimes even they're going in closets on the patio, but that's a bit of a loss of important space. Any other questions on water heaters before we turn to heating and cooling? Okay, well, heat pumps to me are the easiest thing to switch from mixed fuel to all electric. Many contractors have been installing heat pumps for decades already. The Western United States is a bit of a laggard, in fact, in heat pump adoption. The rest of the world has truly embraced this technology. So don't think of it as a weird experimental thing. And really all it comes down to is it's like an air conditioner, but reversible. The picture on the left is the typical air conditioner cooling mode. And what it's doing is, yes, it's blowing cold air in the house, but what it's really doing more than that is the refrigerant is able to recover the heat that's accumulating in the space inside through that indoor unit, and then pump that heat out to the outdoor unit. And what the outdoor unit does, it's a heat rejection device. It dumps that heat outside, and now the cooled refrigerant can come back into the house, and you'll in effect blow cold air into the space. I don't know about you, but I used to see that outdoor unit growing up, the big cube in my backyard, and I thought that fan was blowing cold air in the house. I never even thought about it, but it's a heat rejection device. Now, when we turn to winter, the picture on the right, there's enough heat in the ambient air outside to harvest that and use the compressor to superheat the refrigerant, pump that refrigerant in the house, and now we're rejecting the heat inside the house. Now the spent refrigerant goes back out. And they make heat pumps of various types, that some of which can work down to into the 30-degree Fahrenheit range. Others can work down to 0 or in the negative Fahrenheit, cold weather heat pumps. So there's heat pumps for all climates, and Minnesota is a leader in heat pump adoption, so is Maine. So we certainly can make them work here in California. And mini splits are ideal for ADUs. Instead of the conventional gas electric split system shown on the left, which is a complicated system to install, even though we've gotten good at it. Gas line, flue pipe, ducts up in the attic. We can do better and simpler with a mini split. The ductless mini split, as you can see, outdoor unit, indoor units connected by refrigerant lines. It's a much simpler system, and it reverses direction when the seasons change. A ducted mini split system has the same inverter driven variable speed capability that the ductless mini split has, but no flue vent pipe and usually shorter duct runs. They're usually the most efficient if you can choose the lowest static pressure distribution system possible. So they tend to be more clustered duct runs. Tim says, I have no area to put the condenser. Flat roof, absolutely. Yeah, the outdoor units go on flat roofs all the time, sometimes behind screens just for, making sure no one can see it. But often you can't even see it if you set it back from the parapet wall a little bit. Yeah, that's a great place for it. We've all seen, even on steep slope roofs in our neighborhoods, probably they'll build a platform on the backside of the roof and put the outdoor unit up there even. I've also seen them on brackets attached to the wall. So these are super efficient because of what I just told you, their variable speed mini splits are. So a lot of the time, instead of just running until it meets set point at full speed and then stopping and waiting for the building to heat up or cool down enough to be needed again and then going full blast, these are going to ramp down to the same speed as the rate of heat gain or heat loss of the house. And so most of the year, they're able to spend a lot of the time running at low load when they're most efficient, instead of cycling on and off again like the systems we're used to. So here's a cutaway diagram of a ductless mini split heat pump. You see the indoor unit is connected by refrigerant lines to the outdoor unit. So there's no energy loss from ductwork. Check your manufacturer's literature, but you can link multiple indoor units to a single outdoor unit, up to 8 for some manufacturers. And the indoor units can be different types. You could have one outdoor unit driving 4 high wall units like shown here, and a ducted mini split in another part of the house, or a floor mount in another part of the house. So very flexible configurations are possible. And in our world of energy code compliance, big compliance credit through what's called the variable capacity heat pump credit, which makes your project easier to comply. So our ADU has one of these ductless mini splits. Here you see the great room. On the right is the indoor unit for the great room. And on the other side of that wall going down the middle is another indoor unit for the bedroom. And that covers the 1 bedroom, 576 square foot footprint just fine. The cat is providing scale on the left. That's the outdoor unit. I think we installed a 1.5 ton, more than enough for this ADU. Now, ceiling cassettes are another option and an alternative to the high wall unit. Generally more attractive by most people's judgment. The one on the left is a 4-way, put it generally in the center of the room. The one on the right is a one-way designed to be installed at the wall. Note that all these heat pumps are going to make condensate. So you need to locate the indoor unit, whether it's high wall or ceiling cassette or floor, somewhere where you can drain that condensate. So this kitchen location's ideal. Center of a room, sometimes not as ideal. And so you need sometimes install condensate pumps when you don't have an easy path to drain the condensate water. Oh, there's the ceiling cassette in the center. Sorry, I thought that was already on there. Yeah, Tim, I think it's 8 that I've seen, max number of indoor units for an outdoor unit, but check with your manufacturer. Now, ducted mini split is a popular option with many of my architect clients for aesthetic reasons. It allows you to have traditional aesthetics. If you run the ducts in conditioned space like shown here, you don't have duct losses to worry about, but they still modulate up and down according to the need in the space. And there's a new compliance credit coming for these ducted mini splits, but not in 2023 and probably not in 2024, unfortunately. The CEC still hasn't released that, known as the detailed VCHP credit. But when that's released, it'll really make a wider range of heat pumps able to take advantage of that credit. Jason's installed 8 ductless cassettes with one out. 8. Yeah, great. And this is what the aesthetics can look like on a ducted mini split or any split system for that matter. Some of my LA architects really like that clean, linear diffuser look. They also make packaged heat pumps. And these are going to be more economical. They're not going to require ducts. The one on the left is known as Epica, EPHOCA, made by an Italian company. And you can see quite attractive, and it's going to provide heating and cooling to that space in one unit. The one on the right looks like a traditional PTAC, packaged terminal air conditioner, but instead of having a toaster element for heating, it has a heat pump. It's reversible. So these are good economical solutions for multifamily buildings. Oh, I should mention, there's a project in New York City right now. The manufacturer is called Gradient, where they've devised a heat pump that sits over a windowsill. And so they're electrifying large New York City multifamily buildings with that window unit heat pump. So a lot of options there.
And Nick, there was a question from Deborah, and you might have already answered this question in your last segment, but it was just the installing a heat pump using existing ducts versus installing a mini split, and if there was an argument for one versus another.
Thank you. I missed that. Well, I would say the main argument is that existing ducts are typically very leaky. And even if you're installing a new gas furnace, it's worth duct leakage testing those ducts and seeing how they're performing. The standard for new ducts in the energy code is 10% leakage is the maximum. So if you test those ducts and find you're at 30%, as I suspect you probably are, then you're paying to heat and cool that air and losing it in the attic. So that is an argument to ditch that system and go with a mini split instead. If on the other hand, you've got pristine ducts that haven't started leaking, you know, then a ducted system could make use of your existing ducts. That said, usually the ducts and your old HVAC system have been vastly oversized for the load, And it's always a good idea to get your HVAC company to do a load calculation of your house, especially if you're modifying the envelope and giving it a deep energy retrofit, because you'll find you need much less tonnage than is currently installed in almost every case. HVAC contractors tend to install far too large HVAC systems for fear of getting called back. Yeah, they could also replace the ducts in the attic. Yeah. And if those ducts and the old system were oversized, well, they could right-size the new ducts for the new heat pump. They also, by the way, we're focusing mostly on mini splits here, which are the variable speed ones. They also make what I call dumb heat pumps. They're just on or off single speed. They're going to be a little bit less money than a mini split. And so you could even install one of those in place of your gas furnace air handler. But I would point you to these variable capacity heat pumps as, you know, they're going to pay for themselves in their efficiency. Thanks for that. Clothes dryers. Heat pump dryers I've become a big fan of. They also make electric dryers. Again, the toaster oven, the toaster approach. But when my gas dryer developed a crack in the drum, and this was right during COVID, and I couldn't get a contractor to come out to repair the drum. I'd read about heat pump dryers, so I started doing the research in earnest. And our dryer was in an interior closet right outside my daughter's bedroom door, and the vent went out in the crawl space and dumped the hot, moist air by her window. And I was thinking, knowing what I know about the danger of combustion gases, are they coming through the drum now that the drum's cracked? Is she breathing them when it blows out by her bedroom window? So I just couldn't deal with the guilt. And I went ahead and bought one of these Miele heat pump dryers. I stacked it right on top of my LG washer, and it's worked great. And what I discovered was it heats clothes at a lower temperature than standard dryers, which means less lint on the screen and gentler on the clothes. And it doesn't need the vent pipe. It's not blowing that hot, moist air out. It's condensing the moisture out of the air as it emerges from the drum and pumping the water down the drain. So these are great for locations where you don't have an exterior wall, or you can't run the vent down into a crawl or an attic. Just simplifies the whole washer dryer install. Yeah, and I've found mine uses 10 to 15 kilowatt hours a month, very efficient. The same heat pump concept that we've been talking about for HVAC and for water heating applied to clothes drying. We liked it so much that we got this stacked Miele pair for the ADU. And oh, the other thing I often hear, aren't they slow? Well, not really. The gas dryer we had did a load in about 50 minutes, and this heat pump dryer takes about an hour. So it's really not going to make a difference on your laundry throughput. Even better idea, which Redwood Energy preaches, get a combination washer dryer heat pump unit with a single chamber, and it'll wash it, then dry it, and you don't even need to move it from one chamber to the other. Oh, I should mention, this heat pump dryer is 120 volt, just like Jason's saying. So I didn't have to run special circuits at all. Although some electric dryers and heat pump dryers do require a 240 volt circuit, Some don't. And mine was very easy to install.
Nick, can I ask a question?
Yeah.
There you compared the efficiency or the energy savings rather to a gas one. Is it similar for a heat pump that it's almost 2 to 3 times equivalent or more efficient than the electric counterpart of an electric dryer?
Yes, that's right. If you've got an electric dryer, you'll have savings going to a heat pump dryer because of that 300% efficiency of the heat pump. Yeah, good question. And I found definitely it's a push or small savings versus a gas dryer on utility costs. Although it's hard to measure the gas usage of your dryer, right? No one's metering it separately. Heat pump dryers are a little more expensive. Yeah, I think I paid $1,300 for this. I think it was $1,100 during COVID, but I think they're up a few $100s since then. But Miele is a very good brand. You probably find something a little bit less, but they are more expensive. That was, I think that was $500 of the $1,000 in upgrades that I paid for on the ADU. But what would you spend running that terrible tin pipe? Certainly a few $100s. All right, so I'm a big fan of those. Let's talk about utility costs. So I'm an energy modeler, and energy modeling allows us to estimate utility costs in a way that is not often done. And I've built a massive spreadsheet that calculates utility costs under today's PG&E and SCE rate plans with NEM 3 taken into account. In fact, I'm going to present on that later this month at the Quebec conference. So if I model my ADU as a mixed fuel ADU, and I modeled it as a prescriptive design mixed fuel. So I gave it a heat pump for water heating, even though it's mixed fuel. That's, nice of me. Makes it compare more favorably than it would if it was a gas water heater. And then I gave it a gas furnace, an upgraded 16-SEER air conditioner, and a typical building envelope with a 4 kilowatt solar system. And these were the modeled utility costs of that ADU in 3C REN territory in the chart in climate zone 5, about $2,000 a year. Some of that gas, some of that electric. When I switched to a heat pump for water heating, a ductless mini split with the HRV, and I built the ADU out of SIPS panels, which we'll talk about in a minute. But these are continuous insulation, really tight building envelope elements. And I gave it a 4 kilowatt solar system, although this says 2.6. I'll correct that and send you new versions, Sarah. $649 in utility costs estimated there. And when I looked at it in climate zone 3 and climate zone 12 for prior presentations of this class, I saw a similar relationship. 1,200, sorry, it's like 1,550 mixed fuel, 871 all electric. So this all electric with solar, there's really some alchemy there. It really works well. You've got efficient all electric systems with much of their usage supplied directly by the solar panels, so the utility doesn't even know about half of your usage. And then the other half, you have value, you have credit for exports, and you're pulling the electricity off the grid when the sun goes down. So when I looked at that as a financial investment, that $664 in savings at a cost of, say, $9,000, that's a 7% return on investment that most people be happy with in the stock market, and very low risk, right? Plus no gas meter, protection from gas rates going up, indoor air quality benefits, comfort, and rebates. There's a lot of all electric rebates out there. I'm going to give you a link to some of the programs in case your projects might qualify. We're at this stage right now where we've got proven technologies for electrifying buildings, like I just covered, and yet we're giving you the incentive as if they were, emerging products, unproven, and we've got to, prove them. I've never seen incentives like are available right now. So look, the first costs for all electric are compelling, maybe a little bit more. The utility costs for all electric, even with NEM 3 with solar, are compelling as well. I will say, electrifying a house without solar, my modeling shows a slight uptick in utility costs. So really the solar is a big part of it. Now, shell before E except after C. It makes sense to spend a good deal of your budget on the building shell, right? Because that's going to produce savings for 100 years. You don't have to plug it in. Whereas money spent on solar and mechanical systems have limited lifespans and require maintenance. So even in an all-electric net zero carbon home, specify an insulated and tight envelope. I've certainly found with the SIPS panels and the tight envelope we used in the ADU, real performance differences from even the main house, which was, it was a remodel. We weren't able to get to the same less than 1 ACH 50. We were 3.5 ACH 50, which isn't bad, but we'll talk more about what I've seen in terms of differences. Use a high performance attic or roof. Do the air sealing, caulking, and seal penetrations. And today's really good windows and doors really make for improved performance, especially if you pay special attention to the south, where proper overhangs can pay dividends, and the west, where you're getting that late afternoon sun at the worst time of day when the rates are going up and the grid's in most strain. So this project taught us a number of lessons. First, the all-electric systems are performing well without any intervention, with one exception I'll talk about in a minute, because commissioning pays off. So we have an energy monitoring system on my house from SiteSage. It's a current transducer or CT clamp around every circuit, and that allows me to track the usage by circuit. So we did that on the ADU because I'm a total nerd and I use the data for these classes. And I noticed the electricity usage of the mini split really spiking on a day when it wasn't that hot and at like midnight. And I thought, what are they doing up there? What it turned out was happening was in the bedroom, it was calling for cooling, but the wires were crossed. And so the fan turned on in the indoor unit in the bedroom while the coil turned on in the living room. So they were getting just fan in the bedroom, and the coil was dripping. It was icing up and dripping onto the living room floor. Well, my home energy management system really helped me catch that early and troubleshoot it with the contractor, and we got it fixed right away. So just a great example why, you might skip that $1,000, or you might, not spend time checking on things soon after you've finished the project. It really pays off if you do. I've got some pictures of SIPS panels in case you're curious. The thing went up in 7 days, and that was the floor, the walls, and the roof, all SIPS panels. But it took a lot of upfront coordination and planning to do that. I'd say if you did 2 SIPs projects, you'd be ahead of the cost of stick construction based on, getting it down and learning how the process works. So I would wholeheartedly recommend it. But for a one-off project like mine, it's a lot of extra work that probably doesn't pay off in just one project. The HRV, heat recovery ventilator we installed for our tenants, it's a really nice upgrade to health up the space. You're getting fresh filtered indoor air, and you're pulling out from the bathroom and the kitchen the stale, moisture-ridden air continuously. And when you combine SIPs and a recovery ventilator and a ductless mini split, there's no need for an attic anymore. So vault that thing. And that's what we did. And it really makes a small ADU feel more livable. Now, building above our garage the way we chose to do costs at least $12,000 more than if I were building on the ground. We had to upgrade the foundation. Even though the energy code gives you, an easier path on walls, you still need to make it structurally sound. I should mention that if you use SIPS panels, your structural engineer will have to use different numbers and calculations than for standard wood framing. So you need to pay a little extra time to that too. I would say add them all up, and the upgrades to get this house from typical to net zero carbon cost about $15,000, with most of that being the solar panels. And the cost of construction, $500 a square foot, right? That's a lot. But that's what it goes for these days. I remember naively thinking I could get this thing built, in the low $100,000 range, but it was over $250,000. Hey, here's SIPS panels. They came on a truck. This did the whole ADU. They're all numbered because I sent them the architectural drawings. They sent the shop drawings of the panels and how it would be divided. I approved it. The structural engineer used those numbers in his calcs, and then they produced the panels and ship. And you see the gray graphite EPS splines on the front of the truck by the driver. Those join the panels together. So, much less thermal bridging than a standard framing project, much less air leakage than a standard project, which is why I was really excited to do it. So the plant took the drawing on the left, my architectural drawings, and turned it into the drawing on the right. You got to pay some attention to make sure that's all done right, because these are harder to modify in the field than stick framing. And here you see them going up. You see the old garage. They laid down the floor on the left. They just used a big front end loader. And then they put the panels up one at a time for the walls and then the roof. 7 days. My neighbors were astonished. The walls 2x6 R23 continuous is equivalent to 2x6 R21 plus an inch of rigid foam R5. The floors are 2x12 for rigidity, not insulation needs, R45, and the roof was R37. You can see the roof panels up there. As I said before, I really like recovery ventilators. I've got them in the main house and the ADU now, really mostly for improved indoor air quality, but there's also a nice compliance credit in Title 24. But realize they are going to use more electricity than standard exhaust ventilation. And you can see the vaulted roof because the HRV replaces the bathroom exhaust fan. In the mechanical code is a little clause, seldom used. If you have continuous 20 CFM of exhaust in your bathroom, you don't need an extra exhaust fan. So that's what we did with our recovery ventilator. It performs both functions, the whole house indoor air quality and the local venting of the bathroom. Ductless mini split doesn't need an attic for ducts. and the SIPs are roof and insulation in one step. So here are those net zero carbon upgrades, the solar panels, the SIPs panels. I called that cost neutral because lumber was expensive at the time of construction. And my GC said, I think it would have been about the same for standard lumber and all the framing. Ductless mini split neutral, heat pump water heater, about neutral, heat pump dryer a little more, induction range a little more. HRV, hey, that wasn't required. That was entirely more. And they required me to put in this dual meter panel, one for the main house, one for the ADU. That was, the ADU has a 100 amp sub panel and the main house has a 125 amp panel. Both are all electric with that size panel. So don't let someone tell you you got to have 200 amps or even you got to have 400 amps to electrify a building with solar. There's the heat pump water heater I'm about to take you to. There's the Frigidaire induction range with the vent hood from the microwave above it. Make sure you run those to outside, not recycle. Here's the HRV I'll show you in a minute. That's in my garage under the ADU. Okay, here's some incentive programs. I won't go through them, but just know that there's good money out there and you can research it. Some are for new construction, some are for remodels, some are regional programs. And 3C Ren, in fact, has a regional incentive program coming back sometime next year, as Sarah mentioned. So when you look at the numbers as a financial investment, we spent about $280,000 on this thing. The interest expense on that is about $10,000 after tax. Figure other expenses, $5,000. So it's a $15,000 cost, and rental and utility income was $31,000 in year one. We're renting this for $2,750, and I could have rented 10 of them. So the net income is 6% return on investment, and the value of our property, I believe, was at least $280,000 higher at the day we finished it. So you're going to recover the full investment whenever you choose to sell and make 6% on your investment. That's a pretty good deal the way I see that. And there's no way to invest $280,000 in real estate except, you know, exotic mutual funds like an ADU allows you to do. The economics of modular factory built are similar, but you're going to pay a little bit more for an equivalent modular ADU because they're taking all the heartache out of it for you, or much of it. They're going to do the site prep, the permits. So this one, for example, from Abodu is an ROI of 4%. Still not bad, and you save all that heartache. In terms of carbon emissions, look at the difference. I just modeled this today with updated carbon emission factors. And it's not 50% less when you add a 4-kilowatt solar array. It's almost zero. And that's what we modeled it to be, net zero carbon. And here are the first year carbon emissions. We tracked them. And you can see some days the carbon emissions are positive, other days they're heavily negative. And I'd say we're right about zero net carbon, with the pluses equaling the minuses. The actual energy use I've been really happy with. 9 kilowatt hours a day. The heat pump's about 2 of that. The HRV is 1.5 of that. Like I said, there's a lot of electricity use in those recovery ventilators. Worth it, but heat pump water heater about 1 kilowatt hour a day, and everything else, the plug loads, the hair dryers, TVs, the fridge, are about half of the total usage. That's what happens when you build efficient. Notice the heat pump chart on the right. It's got usage, and then it disappears. That's winter time where the green bars disappear. That's because what we found out is the SIPS envelope with 0.8 ACH50, we worked really hard to seal it, is so efficient and tight that it heats itself from the heat of the people and the refrigerator and the cooking with virtually no need for the heat pump in winter. Isn't that incredible? And I took this up with a colleague of mine, and we presented it at last year's Quebec conference, in fact. We looked at all the interior heat sources, the heat gains of interior loads. And sure enough, if you build a small house with an efficient envelope, there's much less need for heating than in a standard size single family home. The actual usage is about 30% lower than modeled. And the solar system is producing about double what it's using on average. That's what it took to get to zero net carbon with all the hourly factors factored in. So it used about 3,000 kilowatt hours. A typical household uses twice that plus 400 therms. So when you think about it, this ADU, a home for 2 people, uses 1/5 as much energy as a typical home. So something to be said for small living. And the water heater usage is shown there too, monthly. Very efficient. So you can't answer this because Slido stopped accepting my payment from Slovenia, but the ADU is using about 10 kilowatt hours a day, which is 1/5 of what a typical California home uses. Pretty cool. All right, let's get to this if we have time. Before I take you to look at the heat pump water heater. All right, let's go. Sarah, do you know how to spotlight me so I get bigger?
On my end, you already have.
I'm full size?
Mm-hmm.
Oh,
Yeah.
okay. Well, how arrogant of me, huh? All right. So the ADUs above us, am I still coming through okay?
Yeah, you're good for me.
Okay. The ADUs above us, and we're in my garage. And I wanted to have the heat pump water heater somewhere I could check on it and maintain it and stuff, right? So this is a 50-gallon Rheem heat pump water heater. You see the heat pump is this part up. The tank is that part down. These are the backup electric resistance elements that kick in only when needed. It's got a control panel. It's right now set to 120. Airflow is really key, like I said, because it's pulling the heat from the garage around it. The inlet is back here by the spider webs. I didn't clean up because I want it to look realistic. And it has an inlet air filter here. Looks like it's time to clean it, doesn't it? So if you're installing a heat pump water heater, make darn sure that they leave this accessible, because you're going to need to do that every few months. So the air comes in here in the back and it blows out here on the side. So as I said, here at my workbench, I get cool air coming out. That's favorable for me, but you've got to think about that if you're installing one of these in a mountain community where it's really cold, that cold air wouldn't be welcome, would it, much of the year? So you might want to install a duct to take that outside. You see it's got a condensate line. Every heat pump makes condensate. So that's just going out the wall to my landscaping. Completely safe, standard water. You can also run that to a drain. The hot water comes out here. The cold water goes in there. It was running earlier. I wish you could have heard it run because, yeah, it makes a little noise, but like a dishwasher does. This is a 240 volt, 30 amp heat pump water heater, as most of these are. So I had to have an electrician run that circuit for it. But the one for the main house is a standard plug-in 120 volt, and it's performing just as well as this one. Any questions?
Yeah, I don't see anything coming through the chat.
Yeah, and the tenants, they don't even know they have a heat pump water heater. You know, it's just hot water. So here's the HRV. This one's made by Life Breath. I wanted to keep this one where I could see it too, because this panel folds down and I change the filter every 6 months or so. The ducts are running this sub ceiling here, and then I fished them up into the walls and into the space. And if you look at the slides when I send them to you, you'll see little round ports on the wall. That's a supply or an exhaust port of the recovery ventilator. So there's an exhaust port like that in the bathroom. There's an exhaust port in the kitchen, and there's a supply port in the living room and the bedroom. So very simple setup for a small ADU. And they probably don't even know they have amazing fresh filtered air either. But, you know, they're probably healthier for it. Oh, Jason says there's some 240 volt, 15 amp available. Yeah, I think that's right. They might have a smaller resistance element. Any questions on recovery ventilators? All right, then should we go make some rice?
Sounds good.
Now, I can't show you the systems in the ADU because they're up there. It's rented, but I can say they're very happy. And in terms of return on investment, we decided to roll the utilities into the lease because we basically prepaid for all their electricity when we put the solar panels on. So we just put a rider on the lease, you know, add a little bit more for utilities, and we pay their bill. That also means they don't have to set up a separate account with the utility companies. So that's worked well for us, and I think helps the return on investment a little. All right, now we're in my kitchen. We chose to do, rather than a slide-in range, we did a drop-in induction cooktop and an electric oven below it. So a little bit higher end setup. But, you know, I think I'd be just as happy with a slide-in. You can see the surface is pretty clean. It's extra countertop if you're in a small kitchen, because you can do something with this, whereas you can't do much with a gas cooktop with those big, you know, metal grates. It also if your kid reaches over the edge here, you know, and you're cooking back here, they're not going to feel any heat. So real safety advantages in that sense. We've got 4 burners. The 36-inch ones have generally 5, and they're different sizes. A lot's made of the fact that they only work with some pots and pans. Well, this is an ancient emerald pot. I promise you it's clean, but that's how old it is. And as long as a magnet sticks to it, it's going to work on induction. It just needs to be ferrous. It needs to have iron in it. So yes, some pots that don't have iron in it won't work. But it's not a huge expense to get a set of pots and pans that have iron in them. And generally now, you want a flat surface too. Generally now they say induction ready if they work with induction. So let's just start some rice. I didn't want to have the water just waiting, because I thought one of these people is going to accuse me of preheating the water. You think I was right? I think one of these fine people would have thought I was cooking the books. Okay, I got 2 cups of water from the tap. And I just want you to see how long it takes to boil. So the controls are nice too. I'm going to turn this on. I'm going to select this burner and I'm going to put it on max. Start the timer. I like the way this control is like a slide finger control instead of a dial too. And I can see the number. You learn that, you know, on your induction cooktop, where things cook best. Like rice, I generally cook on 4. Oats, I cook on 3. When I'm, you know, stir frying, that's 5. When I've got to, you know, fry something in hot oil, that's 6 or 7. So I just think I like that a whole lot better than medium, high, like I used to have on my gas controls, you know. Sometimes she touches the top and it shuts off the burner. Well, you know what will shut off the burner? Yeah, and it beeps at you. It says, wait a minute, there's no pot present. I really like that because I don't know about you, but my wife's always fussing at me because I leave the oven on after I pull dinner out. So that just is nice protection against that. And you can hear it starting to boil already really quick. So I'm just going to put in the rice. Put this at 4. So look, for me, I wouldn't go back to gas cooking. The indoor air quality argument speaks to me the most, but it's also a really pleasurable cooking experience to have digital controls, to have auto shut off, to have really good temperature control, and no extra heat, right? It's just putting the heat right in the base of the pan. Like I said, if I'll rest whatever I'm cooking with on the edge of the pan, and unless I'm doing something for an hour, it's not even going to get hot up there. I like that. You see, it's 9 years old and it looks pretty good still, easy to clean up. People worry, you know, isn't this a glass or ceramic top? Is it really going to last? Well, it's been no problem and we use it heavily. There's also a bridge function. So these 2 burners can be joined and you can put a whole griddle on them and that whole surface is magnetized. Any questions, you guys? Oh, there's a few scratches, yeah, but not much. Yeah, that's right, Deborah. Separate cooktop and slide-in range.
I will say your comment with the wooden spoon, putting it on the pot. I have a gas stove because I haven't been able to upgrade it yet, and I always put the wooden spoon on the pan just because.
Uh-huh.
And there was a black singe mark on the spoon, like it was about to catch fire.
Yeah.
And I didn't realize it. So that speaks to me.
Yeah. So I really think it is myth that the cooking experience is somehow better on gas. Now, we often get feedback when we teach some of our all electric homes classes. You know, what about roasting green chilies? What about wok cooking? Well, they make flat bottom woks now that work on induction. I think you've got to have, if you've got from a culture that roasts green chilies, yeah, that's your barbecue can do that outside, you know, but you're right. Induction's gonna struggle with that a little bit. You don't have a direct flame. But these are things I think we can work through, you know.
And there was a question asking if you knew about the hidden cooktops, the ones that go under a countertop.
Well, I have seen some, yeah. Yeah, like you'd have a continuous counter with the induction elements under it. I've seen them. I don't know much about them, but aren't those amazing looking?
I do have a friend that installed one of those under
Yeah.
a porcelain countertop, and he loves it. He said that he doesn't notice any kind of like a less amount of heat getting through. He says that it's as if it's right there on the top. So he loves it.
Wow. Wow. And just from a product availability standpoint, there wasn't that much when we bought this KitchenAid. I think it was $2,000 for the cooktop. But now, I mean, Sub-Zero Wolf has them, GE Monogram has just, and they have beautiful induction cooktops because some families really seem to want that like conversation piece range, right? That beautiful gas range painted bright red or whatever or yellow. Well, I think we're to the point now where there's equivalent induction models too for that, you know, someone who's like a performative cook who wants that type of feel. You can get that in induction too now. All right, you want to see the dryer? We won't tell my wife that I didn't clean up before you all got the tour. All right, so this is our stacked washer dryer. Remember, this was a stacked LG pair originally when we remodeled in 2015. Then we put the Miele dryer on top of the LG washer. And then so we put the pair in the ADU and we were jealous. So we got the matching Miele washer later. So here's the heat pump dryer. Oh, my wife's going to be so mad. So it's typical. You've got a filter here. There's two filter surfaces to clean there, and a third one here. This is called the plinth filter. And this is because you really don't want your coils in a heat pump gunking up. See the coils in there? So there's this third filter that we vacuum off and it warns you when it's time, probably every 3 weeks for us. We have to vacuum the plinth filter. But the moisture goes straight down the drain back there, along with the washer drain. The 2 pipes just go in there, and I spray foamed up the vent from the old gas dryer and don't use it anymore. Now, if you don't have the ability to get to a drain, this is crazy, but you can accumulate the water in here and dump it periodically. So you can configure it to be completely, I guess, portable. So they're blowing the hot air in through the drum. The moist spent air comes through the drum, and then the compressor pulls the water out of it and pumps it down the drain, reheats it, sends it back again. So it's a closed cycle. Pretty cool. I did have to adjust it from factory settings to be 1 setting drier, because originally I found it wasn't getting them all the way dry. And then once I did that, everything comes out good. Any questions on the heat pump dryer? Oh, okay. Deborah has an Australian cousin. I lived in Sydney till I was 8, Deborah. So maybe that's why I wanted a heat pump dryer. And there's a lot more models than when I was looking, and larger models. Like if you're a big family, that Mealy is enough for our family when all 4 of us are home, but any bigger, you'd probably want a bigger one. Those are available now too. And I think Jason was saying he has a combo heat pump dryer washer. And is that a big one, Jason? I forgot what you said. Yeah, that'd be bigger than what I just showed you, I'm pretty sure. Let me go back to my slides and just finish up real quick. So I found small home utility bills are smaller. You know, the benefit of small living. And you can look at these statistics. Look at the charts on the right. This was the hottest day the other year. It was a record day on the grid, so it made it somewhat, you know, memorable, remarkable. You seeing that still okay, Sarah?
Yes.
All right. Look at how the solar production in the ADU and the late evening usage as the sun goes down is so much more grid friendly than the bigger main house, which is cycling on and off. That's the air conditioner cycling on and off. And there's huge spikes late in the evening. And I find this to be very true when I look at the ADU versus a main house with a typical air conditioner. So I got some links there, project credits. There's a form there and my email address. I'd love to hear feedback as you embark on your all electric or ADU projects and help you however I can. Back to you, Sarah.
Yeah, thanks, Nick. So just in closing, as a reminder, if there are any questions about Title 24, Part 6, Part 11, we have our Energy Code Coach service. We have a web form on our website. We also have our hotline, and we have Energy Code coaches that can help you through those questions for your projects. And then we also have AIA and ICC learning units available for today's course. And you'll all be getting a copy of the slides, a link to the recording, and a survey in your email. And that reminds me, I will launch a poll just here in Zoom. These just help us gauge courses, help us kind of think of new courses, just make sure that we are providing the information that is beneficial to our community. So it really helps us if you take those polls and the surveys. And then I also added some upcoming courses. We have an in-person in San Luis Obispo passive design build boot camp. It's at the People Self-Help Housing. It's a 5-day training. It's free. So if you are interested, you can click that link. And then we have a couple other courses there, as well as our full catalog on our website. And with that, we still have a few more minutes. So if there's any questions, please feel free to unmute and feel free to ask. If for those that need to get going, thank you for joining us. And yeah, we can stay on until about 4 o'clock.
And that October 9th class is mine, retrofits when you have constraints with your electrical panel, which came up with a few of you. So welcome you to attend that.
Hey, this is Jason. I just
Jason.
wanted to say, Nick, you did a great presentation. I'm a general contractor in Orange County area, and very familiar with a lot of people out in your guys' territory. I used to be the energy coach for Santa Barbara County for 4 years. So I got back into doing deep energy retrofits and passive house builds. And I think what you did was a great example of how you can take an existing home and add on to it with SIPs and other great initiatives. So yeah, we do a lot of this. Most of our clients actually give us a call because they want to get off gas, go all electric, upgrade their panels, install solar, backup batteries, and then electrical charging for their vehicles. I just did my first gas cap off with SoCal Edison, and pretty impressive on what they need to do. And if they do something wrong, I think the whole city would probably, or that neighborhood would probably lose a couple of homes. The way they cap the lines, it's pretty dangerous what they do, but they do keep everything in control.
Wow.
Yeah, if you've ever seen the process of capping off a gas line, they actually do it while there's still gas in the line, and they torch it until it gets super hot, and then clamp it down and cut it off. And yeah, I'm like, well, what happens if you mess up? He goes, well, we won't know because we won't be here.
Wow.
It just basically it's like dropping a bomb. But
wow.
Everything that you're doing, like the water heaters, we do a lot of the reams. We're usually upgrading to the 65 gallons now because they want us to go as a storage battery for hot water. 65 gallon with the mixing valve built in. So yeah, just everything that you're plugging is I'm an advocate of it all. And thank you very much for a great presentation.
Jason, it's great to hear someone out there is doing this at scale too. So keep up the good work.
Thank you.
I'm glad you loved the tour.
Yeah, I was going to say, Nick, we haven't really done a course like that before, and I thought it was so great to see those appliances in person.
Yeah, and to live with them, for several years, you learn valuable insights that you don't learn just from attending seminars. So that's what I try to present.
I got one other question to add. This is Jason again. And Sarah, you might know about this. Did you know that the C3 REN, for anybody that's also on this call that might want to take passive house training, C3 Ren for the Tri-County area has free training, and it's coming up in the next couple of weeks, I think, or maybe at the end of this month. So if you guys want to make a plug for that, that would probably be anybody here that is interested should inquire, should be part of your guys' training program on that list.
Yeah, is it the in-person boot camp, the one that
Yeah,
is in San
in-person
Luis
boot
Obispo?
camp. Yeah, through
Yeah.
EMU. Yeah.
Yes. Yep. Through email.
There it is. Yeah, October
Yeah.
4th.
Yeah.
Yeah. Yeah. Thanks, Jason. Yeah, we're still taking applicants. So for those that are interested, I haven't taken it personally, but I've definitely heard that it is a great training and people really, really recommend it.
Okay,
Okay, so
Deborah just put something in chat. Can I answer that?
of course, yeah.
Okay. Yeah, so the HERA program is part of the federal IRA. It's geared towards low-income households, which is great, right? We want more of the funding to go to those folks who need it most. And they're usually, well, what they're stated is they're going to be point of sale discounts on heat pumps, heat pump water heaters, et cetera. We found out recently that it's going to go through the tech program, one of the incentive programs that I listed on the incentive slide, which right now gives $3,500 rebates for heat pump water heaters, but it's on hold, unfortunately, but it's supposed to be just around the corner coming back. That tech program is going to also administer the federal HERA benefits, however, whatever shape they come in, but it's taking months to get that program active. There are some programs that also have incentives for electrical upgrades that are necessitated by the electrification project. So look for those. I think there's a $600 tax credit through the federal IRA available for that, 30% up to $600. I want to say Energy Smart Homes and some of the other programs have allowances for electrical panel upgrades too. But you can think of that panel upgrade maybe as future-proofing your home, making it able to do EV charging and solar, and someday bi-directional charging with your EV, as well as, whatever other electricity using appliances we haven't dreamed up yet. So if you are in a panel limited situation, 60 or 80 amps or something, although we've done electrification on 80 amps, you just have to be really careful about it. Welcome to the October class where we'll talk about some of those techniques to make small panels work. Okay, HERA has up to 4,000. Yeah, that'll go a long way.
I had a question regarding attending to, because it seems like it would require to take time off work. Is that correct?
Yeah, that in-person training, it's 5 days, all day training. So it would require time off of work, which we definitely understand is a commitment, but it is a great training for those that are able to attend.
Yeah, it sounds super cool. I was just trying to get an idea. Is that like something that people take their holiday, or is that something that the county covers? Like, how does that work, or would I find out more about that?
It depends on the company. Some companies, like contractors, they'll send a person because they want that knowledge within their group. And other people take time off. So it just depends on their organization. So it's not a clear cut answer, but 3C Ren does cover the training fee, which is about a $2,300 value.
Oh, I see. I'm with the County of Santa Barbara, so I was just trying to figure out, because it seemed like 3C Ren, because one of the 3C Ren staff members stopped by the other day in our office, just from across the hall. So I was assuming that that it was a county program, but maybe I'm not fully understanding.
Oh, it is a county. Yeah, 3C Rent is a county, it's a collaborative partnership between our 3 counties. But time off is not covered by the county, just the training fee.
Oh, I see. Okay, sounds good. Thank
Yeah.
you for explaining.
Yeah, no problem. All right. Well, thank you to those that stayed a little bit longer. It's really, really great conversations, and thank you all for attending. And thank you, Nick, for a great presentation.
Enjoyed it. Thanks so much for hosting.
Yeah, of course. With that, I'll go ahead and end in the presentation and hope you all have a great rest of your day.
Bye, Sarah. I'll send you revised slides.
Okay, sounds good.
Okay,
Okay, bye.
bye.